Welcome to MEI Modelling with Algorithms. We're on the topic of Linear Programming 2, Simplex Method, and this is video 2.4 using an online linear programming solver. This is one of 3 videos on LP solvers. We're going to be looking at 3 different types, 3 different pieces of software which can be used for solving linear programming problems, each of which has its own characteristics, its own advantages and disadvantages, and we'll be mentioning those as we go through. Now, in the earlier videos on this topic, we've been looking at the simplex method, and we've been looking at it for relatively small problems, and even in those cases, there's quite a lot of work involved doing it by hand. So really, if this is going to be a practical use, we're going to need the help of technology. So this is the purpose of the remaining videos, is to introduce you to some of the technology that can be used to do this, and in this video in particular we're going to be looking at an online solver which can be found at this URL. Okay, so if you type that into your browser, then you can access that. Now what you can see here is a little screenshot from this solver, and if you click on the example button, it will show you an example of what a linear program problem might look like once you've entered it in the format that they require. So it's very straightforward. You're really using plain English, maximize an objective function subject to, and then you're entering the constraints in that way there. A couple of things to point out. Firstly, it will accept both greater than equal to as well as less than or equal to, and it can also be used for both maximization and minimization. One thing this software can't be used for is integer linear programming problems. So there is what appears to be an integer mode, but that is somewhat misleading. It's not a constraint on the values that they have to be integers. It's just about how the values in the tableaus are going to be displayed. So watch out for that. If you want to do problems where you're restricted to integers, you'll need to use one of the other 2 pieces of software that we're going to see. So here's a very quick example showing the software being used. This is the problem that we're going to try to solve, and you can see here what we've typed into the solver in order to do that. Once we've done that, then we click solve and it will solve it for us, and we need to interpret the final tableau in the correct way. Now there's a very slight difference in the way that this is set out compared to how we've done it by hand. That is that the objective row is the bottom row here, and the objective function, the column, is this one here. So it's the rightmost column before the final one, which is obviously the numbers that are on the right hand side of the equations. So as long as you realize that, everything else is the same. So if we're going to interpret this solution, we need to look carefully for the basic variables then at the end. Watch out for this one. You might think that y is basic there, but if you look carefully, there are actually 2 1s there. So y is a non-basic variable, z is basic, and S2 is basic, and P is basic. So how we would interpret that is that, remember, we look, for example, at that one, and we look at the number which is at the end of that row. So that tells us that x equals 6. Because y is non-basic, we'll say that y equals 0, and we can say that z equals 1.5. So those are the values of the 3 original variables that we would choose to get the optimal solution, and by choosing those we get a value of p of 25.5. Okay, and if we're interested in the slack variables, then in terms of leftover materials, S1 and S3 are non-basic, so they will have values of 0, so there's no leftover materials from them. S2 has a value of 1, so there'll be 1 unit of remaining materials. or whatever the real life interpretation is of that variable in this case. So as I say, that was a very quick example and a very quick video talking about that online linear programming solver. So that concludes video 2.4, and the next video will be video 2.5, where we're going to see a spreadsheet linear programming solver.